Good evening. We start with sum number 14, exercise 3.4. Find the number of distinct words formed from the letters in the word Indian. How many of them have two ends together? Right now. There are 6 letters in the word Indian. There are 6 letters in the word Indian, which include I twice, which include I, capital I, twice. Comma, N twice. Therefore, number of distinct words equal to 6 factorial upon 2 factorial into 2 factorial, that is 720 upon 2 into 2. So it comes out to be 180. So this is the first part. In second part, what is asked? How many of them have the two ends together? Okay. Next line. We consider two ends as a single letter. We consider two ends as a single letter. Then this letter and remaining 4, then this letter and remaining 4 that is in all 5 letters, that is in all 5 letters, which include I, capital I, which include I twice, which include I twice, can be arranged in 5 factorial upon 2 factorial equal to 120 upon 2 equal to 60 ways. Therefore, 60 such words can be formed right now. Now this is again a simple one, sum number 15. Find the number of different ways of arranging letters in the word Platinum if A part, the two O's are never together, B, consonants and vowels occupy alternate positions. Now in the word Platinum, the number of letters is what? 3, 3, 6 plus 1, 7, of which O repeats twice. So what is total number of arrangements? It is 7 factorial upon 2 factorial comes out to be 2520. Now next part, the two O's must not come together. Now when the two O's are together, the total number of letters will be what? 6. Why? Because we consider two O's as a single letter. So this letter and remaining 5, that is in all 6 letters. So these can be arranged in how many ways? 6p6, that is 6 factorial equal to 720 ways. So out of 2520 arrangements, in 720 arrangements, 2 O's are always together. So in the remaining, that is in 2520 minus 720 arrangements, 2 O's are never together. Okay. Second part, consonants and vowels occupy alternate positions. Now there are 4 consonants P, L, T, N and 3 vowels A, O, O. The possible arrangements in which consonants and vowels take alternate places is what? Arrangement has to begin with a consonant, then vowel, then consonant, then vowel, then consonant, then vowel, and then consonant. Why not with vowel? Because number of vowels is 3 and number of consonants is 4. That is why. Okay. So 3 vowels can be arranged in how many ways? 3 factorial upon 2 factorial ways. Why? Because O occurs twice and 4 consonants in 4 factorial ways. So number of such arrangements is 3 factorial upon 2 factorial into 4 factorial. Comes out to be 72. Actually, after this in the textbook, they have given circular permutation, but we will discuss that at the end. Now we discuss combinations. Definition is simple. What is combination? Combination is just selection. Selection of n things taken R at a time. So clearly, in this case, order is immaterial. Now, total number of selections of n things taken R at a time is denoted by NCR. This is called as prefix. It tells us total number of objects available, and this suffix tells us how many objects are selected. C for combination. This can also be denoted by CNR or using this notation also. Okay. So there are 3 important notations to denote total number of combinations of n things taken R at a time. Now, what is formula for NCR? NCR is n factorial upon n minus r factorial into r factorial. I'm going to explain the logic also. I hope you know this part, n factorial upon n minus r factorial. Yes, this is NPR. So in short, NCR is what? NPR upon r factorial. Use common sense. Clearly, number of combinations is less than number of permutations. Why? Because combination is just selection. In case of permutation, selected things are to be arranged. Okay. So let us prove this formula. What is our aim? Our aim is to find total number of combinations of n things taken R at a time. Suppose that number is capital N. Means what? Out of n things, R things are selected. If we decide to arrange those selected things, I know that in case of combination, order is immaterial. We do not arrange them. But if we decide, then R objects can be arranged among themselves in how many ways? RPR, that is R factorial ways. So for each selection, R factorial arrangements are possible. So for n selections, how many arrangements are possible? N into R factorial. But note that in this process, we have arranged n things taken R at a time. So that is NPR. Therefore, n into R factorial is NPR. But Rn is to find n. What does capital N stand for? Total number of selections. That is total number of combinations. So it is NPR. But before that, what is NPR? N factorial upon n minus R factorial. So capital N from this is nothing but n factorial upon n minus R factorial into R factorial. Is that clear? Clearly, R less than or equal to n. So this is the formula to find NCR. Now, can you tell me what is NCN? In all, there are n things and we have to select all at a time. So that is not basically selection, that is compulsion. So what is NCN? It must be 1. Verify. What is NCN? N factorial upon n minus n. That is 0, 0 factorial into again n factorial. N factorial upon n factorial is 1. What is NC1? There is no need to use formula. There are n objects and we have to select only one. So selection can be done in how many times? Well, selection can be done in how many ways? N ways. If you want to use formula, you can. So it will be NC1 as per formula. NC1 n factorial upon n minus 1 factorial into 1 factorial. Now what is n factorial? Factorial of any number is factorial of 1 less into that upon n minus 1 factorial as it is. Gets cancelled. So what remains is n. Is that clear? Now combination is used wherever order is immaterial. That is only selection is to be done. So can you tell me the situations? The first situation is selection of a group, team or committee. C for committee, C for combination. In most of the geometrical problems, I'm not saying all, because vector AB bar is not the same as vector BA bar. But triangle ABC, same as triangle BCA. So in most of the geometrical problem. Then selection of balls from an urn. URN, urn means container. Selection of balls from an urn. So in that case, we go for combination. Selection of cards. Yes, some cards are usually asked in exam. Not only in this topic, permutations and combinations, but while solving sums in probability, we are going to discuss this. So selection of cards, playing cards, I mean. So in that case, we use combination. So in general, any selection in which order is immaterial, we go for combination. Right now, give the title, combinations. Let write down. A combination of n different objects. A combination of n different objects. A combination of n different objects taken R at a time. Taken R at a time is a selection of R objects, is a selection of R objects is a selection of R objects out of the given n objects. Out of the given n objects, comma, the order of choosing not being important. The order of choosing not being important. The order of choosing not being important. Next line. Total number of combinations. Total number of combinations. Total number of combinations of n objects. Of n objects taken R at a time. Taken R at a time is denoted by, see on the screen, is denoted by NCR or CNR, or using this. Then write down formula. So what is NCR? N factorial upon n minus r factorial into r factorial. NCn is 1 and NC1 is n. Now just listen to me. This part is important. Properties of combinations. First one, NCR is NCn minus r. This is interesting. Logic is very simple. What is NCn minus r? Basically, what is the formula? How will you remember? See, prefix C suffix. Listen to me. Prefix C suffix is prefix factorial upon prefix minus suffix factorial into suffix factorial. Okay? And therefore, what is NCn minus r? N factorial upon n minus what? N minus r. So n minus n plus r factorial into this factorial. That is n factorial upon r factorial into n minus r factorial. But this is formula for NCR only. This is very interesting. So what is NCR? NCR is NCn minus r. Particular cases. 10C8 will be what? 10C 10 minus 8, that is 10C2. So combinations of 10 things taken 8 at a time is the same as combinations of 10 things taken how many at a time? 2 at a time. Okay. Now, remark. Consider the above property. NCR is the number of selections of R objects taken from the n given objects. When we select R objects out of n objects, we reject n minus r objects. That is, for each selection of R objects out of n objects, there is a rejection of n minus r objects. Thus, the number NCR of combinations of n objects taken R at a time for selection is the same as the number of combinations of n objects taken n minus r at a time for rejection. That is NCn minus r. Even if you do not understand this statement, no problem. Using formula, we have already verified that NCR is NCn minus r. Such combinations are called complementary combinations. COMPLEMENTARY, complementary combinations. Okay. So if you are asked to find 20C18, you may say 20C18 is same as 20C2, one and the same thing. Okay. Now, next part, if NCX is NCY, then either x equal to y or x plus y equal to n. This is quite logical. See, NCX is NCY, right? But we have just proved that NCY is NCn minus y. So either x equal to y or x equal to what? N minus y. That is x plus y equal to n. I'll tell you. See, particular values are considered. It can be understood easily. See, can I say 10C2 is 10C2? Obviously. Can I say 10C2 is 10C8? Yes, we have just proved that. And that is what? So if NCX is NCY, then yes, x equal to y. Or 2 plus 8 equal to 10. That is x plus y equal to n. Same thing is written here. Okay. Now, third result is important. In fact, we have already proved this when we discussed factorial notation. A few of you will remember this. This is an interesting result. We will be using this in the topic binomial theorem. We are asked to prove that NCR plus NCR minus 1 is what? N plus 1 CR. I repeat, NCR plus NCR minus 1 is what? N plus 1 CR. This is not at all difficult. NCR is what? As per formula, N factorial upon N minus R factorial into R factorial. What will be NCR minus 1? Prefix factorial upon prefix minus suffix factorial into suffix factorial. So you get this. Okay. Now, this R factorial can be written as R minus 1 factorial into R. Factorial of any number is factorial of 1 less into that number. Okay. What about N minus R plus 1 factorial? Same logic. Factorial of any number is factorial of 1 less, that is N minus R factorial, into that number. Now you will notice that this can be taken common because both these terms contain this part. So when this is taken common, what remains in bracket is 1 upon R plus 1 upon N minus R plus 1. Now rearrange the terms by finding LCM and so on. So what remains is this N factorial into N plus 1 factorial of any number into immediately next number is factorial of next number. Same logic for this R minus 1 factorial. See, there is multiplication throughout. So we can rearrange the terms. So R minus 1 factorial into R, which is R factorial. N minus R factorial into N minus R plus 1 is N minus R plus 1 factorial. But note that this is nothing but N plus 1 CR. Right? So just remember this result. You can use this result as standard result. NCR plus NC. Oh, this is not correct actually. This should be NCR plus NCR minus 1, not R plus 1, R minus 1. Oh, I am sorry. They are saying similarly. Okay, similarly. I'm sorry. Now, there is one more result. Result number 4, I will not explain at present because that requires knowledge of binomial coefficients. But result number 5, you have to remember this. This is again common sense. Even if you do not remember this, if particular values are given, you can easily find out that NCR has maximum value when R is n by 2, when n is even, but when n is odd, then NCR is maximum when R is n minus 1 upon 2 or n plus 1 upon 2. So just write down this. Right. So NCR is maximum when R is n by 2 for n even and R n minus 1 by 2 or n plus 1 by 2. Why same for both? Because we have just seen that NCR is NCN minus R, complementary combinations. Exercise 3.6. Find the value of A 15C4. See, you should remember the formula. NCR is n factorial upon n minus r factorial into r factorial. That is prefix C suffix prefix factorial upon prefix minus suffix factorial into suffix factorial. Here I have omitted one step. See, factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. So after cancelling 11 factorial, what remains is 12 into 13 into 14 into 15. But what is 4 factorial? 1 into 2 into 3 into 4, that is 24. Simplify to get 1365. What about 80C2? 80 factorial upon 80 minus 2, that is 78 factorial into 2 factorial. Factorial of greater is factorial of smaller into, go on adding 1 unless you get greater. So it is 79 into 80 upon 2. So comes out to be 3160. C part 15C4 plus 15C5. Now you may ask me, can we obtain these two separately and add? Will we get marks for that? Yes, you will. But if you will write this as 15C5 plus 15C4, this is of which type? NCR plus NCR minus 1, which is what? N plus 1 CR. So 16C5. What is 16C5? 16 factorial upon 16 minus 5, 11 factorial into 5 factorial. Now factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. Okay. So it comes out to be 4368. I repeat, you can find these two separately and add. You will get the same answer. D, 20C16 minus 19C16. You may say we will find these values separately and then we'll subtract one from the other. Yes, that is also correct. But observe prefixes and suffixes. So on 20C16, can I apply? N plus 1 CR is actually what? NCR plus NCR minus 1. Now N plus 1 is 20. So what is N? 19. So this is 19C16 plus 19C15 minus this as it is. So what remains is 19C15. 19 factorial upon 19 minus 15, 4 factorial into 15 factorial. Factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. 15 factorial gets cancelled. What is 4 factorial? 24. So 3876. Second, find n if A 6P2 is n into 6C2. You should know that NPR is R factorial into NCR. So this n must be 2 factorial, that is 2. Or use formula 6P2 is 6 factorial upon 4 factorial. I'm sorry, this should be C, not P. I'll make that change. Now this is correct. So apply formula. What is 6C2? 6 factorial upon 4 factorial into 2 factorial. So 6 factorial gets cancelled. 4 factorial gets cancelled. So what is n factorial? 2 factorial. What is n? 2 factorial, which is nothing but 2. B, 2nc3 is to nc2 is 52 is to 3. Now what is 2nc3? 2n factorial upon 2n minus 3 factorial into 3 factorial. Don't forget to put 2n in bracket. Otherwise, it will mean 2 into n factorial. No, it is factorial of 2n. Okay. Now, ratio A upon B upon C upon D is A upon B into D upon C. Okay. Now, factorial of greater. Let me explain. Factorial of greater is factorial of smaller. Okay, I'll write that step also. Factorial of smaller. Go on adding 1 unless you get greater. So 2n minus 2, 2n minus 1 into 2n. What about denominator? 2n minus 3 factorial. 3 factorial is 6 into n minus 2 factorial into 2 factorial is 2 upon. Now what is n factorial? Factorial of greater is factorial of smaller. So n minus 2 factorial. Go on adding 1 unless you get greater. Okay. Now this is given to be 52 upon 3. Now see whether we can cancel something or not. Yes, we can. This gets cancelled. And here n minus 2 factorial gets cancelled. Okay. So see what remains. Oh. So in the next step, I will take 2 common from 2n minus 2. So 2 into n minus 1 into 2n minus 1 into 2n upon 6. And here it is 2 upon n minus 1 into n equal to 52 upon 3. Now here n gets cancelled. N minus 1 gets cancelled. So see what remains. What remains is, I can say, so this is 4 times. Let's check this. What remains is 4 times 2n minus 1 equal to 52. So what is 2n minus 1? It is 13. So 2n equal to 14. So n is nothing but 7. Better. C part is for homework. Actually, it is find n if n minus 3 is 84. Okay, n comes out to be 9. Now, third sum is again for homework. Sum reads like this. Find R if 14C2R is to 10C2R minus 4 is 143 is to 10. Here, you need not open the brackets. You will have to argue that like LHS, we express RHS also as product of 4 consecutive natural numbers. So R comes out to be 4. Fourth A, find N and R if NPR is 720 and NC N minus R is 120. You should know the relation between NPR and NCR. What is NPR? R factorial into NCR. That is R factorial into NCN minus R. Why? Complementary combinations. So 720 is R factorial into 120. So what is R factorial? 720 upon 120, that is 6. But 3 factorial is 6. So R is nothing but 3. So NPR equal to 720 gives NP3 equal to 720. So n factorial upon n minus 3 factorial into 3 factorial is 720. Now factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. So n minus 2, n minus 1, n is 720 into 6. Now what is speciality of LHS? It is product of 3 consecutive natural numbers. So can we express RHS also in that fashion? Yes, we can. See, 8 into 9 into 10. Just a minute. No, 8, 9, 10. Is this correct? Yes, it is. I'm sorry. Basically, this is NPR, right? Now this is correct. See, what is NPR? I'm sorry. It should be n factorial upon n minus 3 factorial. It is 720. Now what is n factorial? N minus 3 factorial into n minus 2 into n minus 1 into n upon this as it is. Now this gets cancelled, n minus 3 factorial. So it is n minus 2 into n minus 1 into n, 720. Like LHS, we express RHS also as product of 3 consecutive natural numbers. And therefore, n comes out to be 10. So you have to write answer separately. R equal to 3 and n equal to 10. Now this is correct. I'm sorry. This is NPR and not NCR. So not into 3 factorial. Now this is correct. B part. NCR minus 1 is to NCR is to NCR plus 1 is 20 is to 35 is to 42. We consider a ratio of 2 at a time. In the beginning, we say NCR minus 1 is to NCR is 20 is to 35. Use formula. NCR minus 1 is n factorial upon n minus r plus 1 factorial into this factorial upon NCR is n factorial upon n minus r factorial into r factorial. A upon B upon C upon D is A upon B into D upon C. See, this is lengthy but not difficult. This gets cancelled, n factorial. Now, next part, n minus r factorial into, what is r factorial? R minus 1 factorial into r. What about denominator? N minus r plus 1 factorial is n minus r factorial into n minus r plus 1 into r minus 1 factorial is what? 4 upon 7. See what gets cancelled? N minus r factorial gets cancelled. R minus 1 factorial gets cancelled. So r upon n minus r plus 1 is 4 upon 7. So tell me which equation we get. So that gives me 7r is 4n minus 4r plus 4. That is 11r minus 4n. Please check this, equal to 4. This is equation number 1. Now find out equation number 2. Now we consider this ratio. NCR is to NCR plus 1 is 35 is to 42. I omitted one step. NCR is n factorial upon n minus r factorial into r factorial upon NCR plus 1, that is upon n factorial upon n minus r minus 1 factorial into r plus 1 factorial. So eventually this goes to numerator. Now n factorial gets cancelled. Factorial of greater is factorial of 1 less into that. Similarly, in the denominator, what is n minus r factorial? Factorial of any number is factorial of 1 less into that number. Okay. Now see how this can be simplified. R factorial gets cancelled. This also gets cancelled. Okay. So what remains is r plus 1. Please check this. R plus 1 upon n minus r equal to 5 upon 6. So 6r plus 6 is 5n minus 5r. So this is 11r minus 5n equal to what? Minus 6. Okay, this is equation 2. Now we have to solve equations 1 and 2. You will notice that in first equation also coefficient of r is 11 only. So I'll just subtract one equation from other. So equation 1 minus equation 2 gives minus 4n plus 5n equal to 4 plus 6, that is n equal to 10. n equal to 10. And then I'll say put this in 1. So 11r minus 4 into 10 equal to 4. So 11r is 44. So what is r? R is nothing but 4. So you have to write answer separately. N equal to 10, R equal to 4. So that's it for today.